Hello everyone, this side Dr. Nitin Sharma, Assistant Professor, Department of Information Technology, AKGEC Engineering College. So today I am going to discuss about a Prim's algorithm and Kruskal algorithm. So let's see one by one. So first of all, what is a Prim's algorithm? So basically a Prim's algorithm is a famous greedy algorithm. So as you know about it, in a DA there are basically some type of algorithms. So one type of algorithm is a greedy algorithm. So greedy algorithm is an algorithm which is used to maintain an approach to solve any problem in a greedy way. Okay, so it is basically used for finding the MST, minimum spanning tree, of a given graph. What is basically a minimum spanning tree? Minimum spanning tree means a graph where all the nodes are connected in a tree form. There is no cycle in between them. Okay. And to apply Prim's algorithm, the given graph must be weighted. So the given graph have some weights and connected, obviously, and undirected. Okay, so you are having a graph which is having some weights, and obviously the graphs are connected, and that is undirected graph. For example, suppose there is a graph like this is the node and these are the edges, and there is the second graph. Okay, but you can see these two graphs are not connected to each other. So you cannot create a minimum spanning tree for these graphs, right? If I can connect these nodes like this way, so now you are able to create the MST for this particular graph. So the primary condition is that if you are going to apply a Prim's algorithm in any graph, the graph must be weight something, like you have to be weight on every edges, like 5, 6, 7, 9, 1, 2, 7, like this. Okay. And the graph must be connected. Every node is connected to each other, and the graph is undirected. There is no direction in the graph. Now, how we can apply a Prim's algorithm? So there are basically a 3 steps. Step 1, randomly choose any vertex. Any vertex you can choose from the graph. Okay, and the vertex connected to the edge having at least weight is usually selected. So what we are selecting, basically, whenever I am choosing a vertex randomly, we are choosing a which is having a at least weight in a graph. So we can just select it. And the step 2, find all the edges that are connected tree to the new vertex. So whatever edges you are selecting, so you have to be connected the tree for particular vertex. So whenever we are going to create a MST from by using a Prim's algorithm, so the graph, the MST is created in a connected way, right? Find the least weighted edge among these edges and include it in a existing tree. And the last point, if include that edge, create a cycle. If there is a cycle when you are including an edge in a MST and it is creating a cycle, then reject that edge and look for the next least weight edge. Okay. So the primary condition of a minimum spanning tree is that there is no cycle in this graph. Obviously, because whenever I am saying that is a tree means they are having some nodes that are connected in a tree form, but there is no cycle in between of them. But in a graph, the cycle can be already in a particular graph. Okay, and the last step is keep repeating step 2. So these steps are repeatingly until all the vertex are included and minimum spanning tree is obtained. So the second step is continuously repeating. Every time I am selecting edge one by one, edge one by one, until all the vertices are covered. All the vertices are included. You can see whatever I have written here, all the vertices are included. When all the vertices are covered and tree is maintained and the tree is having a no cycle, that tree is called a minimum spanning tree. Got my point? Okay, so the next question is, can a graph is having more than one MST? Yes, obviously. A graph which is having a more than one MST, but whenever I'm talking about a minimum spanning tree, so we have to be select a minimum edges one by one. Okay, let's try to understand an example. So this is the example of a Prim's algorithm. You can see in this example there is a graph, and you can see whatever I am saying that MST does not have any cycle, but in this graph there is a cycle. You can see this is a cycle, this is a cycle, this is a cycle. So graph can have a cycle. Okay, but whenever I am going to create a MST does not have any cycle. So one by one I am choosing randomly a minimum edge from this graph. Okay, So you can see, if you can see, there are some weighted graph, there are some weighted edges, and what are the minimum edge? Minimum edge is this one, 10. Okay, so initially I am selecting this one. So you can see I am selecting this edge and 1 to 6, right? Now, second, what you have to do, you have to see that one is having an edge which is having a weight, connected edge is 28, and 6 is also having a connected edge that is 25. There are two connected edges from 1 to 6. First is 25, second is 28. So you have to choose the minimum weighted edges, right? So the minimum weight, if you can see, so this one is minimum. So I can choose this one, 6 to 5. 6 to 5 is having a weight 25. So I am selecting here 25 edges. Okay. Now, so you can see the one is basically having a edge which weight is 28, and 5 is connected at 2 edge. First is, you can see, that is 24, and the next is 22, right? So these are the three edges which we can select. So which edges we are going to select? Which is having a minimum weighted. So minimum weighted is 2, that means 5 to 4. So let's select this. So you can see I am selected as 5 to 4, that is 22. Got my point? Now next you can see one is having again, I am having here 28. 5 is having one more edge connected, the weight is 24. 4 is having a 2 edge which is having here 18, and 1 is 12, right? So you can see 5 to 7 is 24, 4 to 7 is 18, and 4 to 3 is 12. So now I am having here 4 options. First is 20, first edge's weight is 28, then 24, then 18, then 12. So which one you are going to select? You have to select the minimum one, right? So minimum one is 12. That means 4 to 3 edge should be selected. Okay. So now I am going to select this 4 to 3 edge. You can see this edges is selected. Now further we are going to see what are the options we have now. So now we are having here option that is 28. 5 is having an option 24. 4 is having an option that is 18, and 3 is having an option that is 60. Okay. So now you can see we are having here again 4 options. First is 28, 24, 18, and 16. If you can choose from this graph, so you can see 5 is having option 5 to 7, that is 24. I have already written there. And the second is 4. 4 to 7 is 18. I have already written there. 3 to 2 is 16, and 1 to 2 is 28. So now I am having here 4 options. So which one we are going to select? The minimum one. Obviously the minimum one. Minimum one is this one, 16 weighted. That means 3 to 2. Okay. So now we can choose this edges. So I am selecting here 3 to 2, 16. Okay. Now I am going to writing what are the options we are having here. So first option is that is 28. Next is 24, next is 18, and this is 14. Okay. So again, you can see in this graph we are having here 4 options. First one is 1 to 2, that is 28, 5 to 7, that is 24, 4 to 7, that is 18, and 2 to 7 is 14. Okay, which one we are going to select? Obviously the minimum one, right? So the minimum one is 14. In this example, suppose for example, this edge is having weight some less than like 15. Okay. If in this scenario, I'm talking about in this scenario, suppose the weight is here is 13 weighted here. So obviously the minimum one is 13. But whenever I am going to consider this edge, this is make a cycle. So what you have to do, whenever you are selecting any edge and that edges is creating a cycle, you have to be rejected it. That means you have to neglect this edge and you have to be choose another edges which is having a minimum weight. So minimum weight is after this one is 14, right? This is a one scenario, but in the current scenario, in the current question, you can see the option is only we are having here 14. So whenever I am going to select this edge 2 to 7, 2 to 7, the weight is 14. So whenever I am going to select this, so you can see 2 to 7 is 14, right? So what are the basic problem is, whenever you are going to create a minimum spanning tree, the problem is that you have to be complete or include all the edges, all the vertex. So you can see we are having here 7 vertex. I'm selecting all the 7 vertex. There is no cycle in this graph. So this is called a minimum spanning tree. And the process which I am following from this to this, right? One by one I am connecting edges and making this tree. This process is basically by using the Prim's algorithm. Understood? What are the weight of this minimum spanning tree? You can just add all of them. So 10 plus 25 plus 22 plus 12 plus 16 and plus 14. Right? So this is the total weight. Okay, so weight is 30, 40, 50, 60, 70, 80, 90, and that is 99. So the minimum spanning tree of this particular graph is this, and the cost of this minimum spanning tree is 99. Got my point? And one more scenario you can see here. Whenever I'm using a Prim's algorithm, the graph, the tree is created, it is basically proceed in a connected way, right? Whenever new edge is included, the graph or the tree is increasing or making in a connected way, right? Apart this, if I'm going to discuss about a Kruskal algorithm, this is another famous greedy algorithm which is also used for finding the minimum spanning tree. So the concept of minimum spanning tree is same. You have to be, you have a one graph, right? To apply the Kruskal algorithm, the given graph must be weighted, connected and undirected, just like same in a Prim's algorithm. So same graph, in the same graph, you can apply either a Prim's or either a Kruskal algorithm. You can apply any algorithm. Both are basically a famous greedy algorithm and both are used for the minimum spanning tree. And what are the basic property of minimum spanning tree is that minimum spanning tree is having a all vertex and there is no cycle in between of them. Okay. So let us understand the same thing with an example. And first of all, you have to understand what are the steps are here. So first of all, you have to be short all the edges from low weight to the high weight. Okay. So one by one, you can choose the edges and you can just write down in a table form, right? You can just write here edges and weight. Okay, so you can write in low weight to the high weight. Obviously, whenever I am going to create a minimum spanning tree, so you have to select the minimum weighted edges, right? So you have to be shorted all the edges from low to high weighted. Take the edges with the lowest weight and use it to connect it to the vertex to the graph. So one by one, I am selecting the edge from this table and just draw in a graph. Okay, one by one. And if adding an edge create a cycle, obviously whenever I'm adding edge in a graph, it is creating a cycle. So you should reject him, right? And then go to the next minimum edges. So then rejected the edges and go to the next least weight edges. Okay. Next, keep adding edges until all the vertex are connected. Obviously the step 2 is repeatedly until all the vertex are connected. Whenever all the vertex are included in a minimum spanning tree, you have to be terminate your algorithm and a minimum spanning tree is obtained. Understand my point? Okay. Let us understand this Kruskal with the example. So the same example you can see, the same example I'm already discussing a Prim's algorithm. So the same example, I'm going to discuss creating a MST by using the Kruskal algorithm. Okay. So what the algorithm says, you have to be shorted all the edges once, then one by one you have to be selected and draw it. Okay. So you can see these are the nodes. I am writing all the nodes here. Okay. 1, 2, 3, 4, 5, 6, 7. One by one, I am selecting the minimum edges one by one. Okay. So you can see here the minimum edge. If you can see this graph, the minimum edge is 1 to 6. This 10 is having a minimum edge, minimum weighted edge, right? So I am selecting here. You can see I am selecting this one. Next, If you can see next, so what are the next minimum edge? After 10, you can see the 12. This 3 and 4 is having a minimum weight, right? So I am just selecting this one. So this is basically the first step, which is having here 10. And the second is, you can see I'm selecting here in the second step 12, right? Now you can see the difference between Prims and Kruskal. In a Prims, the graph is basically, or the tree is basically created in a connected form. And you can see I'm going to make a minimum spanning tree, but that tree is created in a disconnected form, right? It is basically created in a disconnected. That you can see this edges is different, this edge is in a different zone. These two edges are not connected, right? But in future they are connected. Now the next minimum after 12 is 14. So I am selected this 14, right? After 14, you can see the next edge is 16. So that means 2 to 3 should be connected. So you can see that 16 is connected. If you can see here, in this step, 16 is connected, right? Now after 16, you can see the 18 is here. But what is the problem? Whenever I am going to select this 18, so this is making a cycle. Got my point? After 16, the minimum weighted edges is 18. If I am going to select this 18, this is making a cycle. So what you have to do? You have to just reject them, okay? And choose the next minimum edge after 18. So after 18, I can see this 22 is having a minimum weight. This edge is having a minimum weight. So I can just choose this one, 22, right? So 18 is rejected. And after that, if I can see the minimum weighted edge is 22. So I am just selected this one, right? So this 22 I am selected here, and the 18 edge which is making a cycle, I just rejected them. Got my point? Next. After 22, you can see this edges is basically having a minimum edge, right? Right. After 22, you can see 22. After that, we are having here 24. Again, the same problem occur here. If I am choosing this 24, what is happening here? It is basically making a cycle. Got my point? So what you have to do? The next step is you have to reject this edge and go to the minimum value. Go to the next minimum edges. So after 24, you can see that the next minimum edge is 25, right? If I rejected this and choose this minimum 25, so is it okay? Yeah, is it okay? Because there is no cycle in this tree. Okay. So in the next step, I just rejected this 24, and choose this 25. Got my point? And now you can see all the nodes, all the vertex are covered 1, 2, 3, 4, 5, 6, 7, and all the vertex are connected and there is no cycle. So this is an example of a minimum spanning tree. Got my point? So this is the way you can apply a Kruskal algorithm. Got my point? So basically, if you are going to create a minimum spanning tree, we are having here two algorithms. First is Prim's, second is Kruskal. And both are basically a greedy algorithms, and both are basically used for creating the minimum spanning tree. If you are going to apply a minimum spanning tree in any graph, there is a minimum requirement. Minimum requirement is that the graph should be connected, weighted, and undirected graph. If these three properties is followed by any graph, you can create a minimum spanning tree. Got my point? And the same example, I already explained that with the Prim's algorithm and already explained with the Kruskal algorithm. Okay. Now, next, see what is the difference between Prim's and Kruskal algorithm. So there are basically some minimum difference between of them. One by one, we can just discuss about it. The tree that we are making or growing always remain connected. As you can see in the example, whenever I am going to create a tree, the tree are making and grow always remain connected, right? The tree is basically growing in a connected form. Suppose there are some nodes, these nodes are connected. So second edges is already connected, right? With this node, right? In a connected form. So the always tree is basically growing in a connected form. But the tree that we are making grow usually remain disconnected. Just like in the example, if you can see, in the Kruskal, you can see the tree is basically creating or growing in a disconnected form. You can see this is a one graph, this is a second graph, right? So these are disconnected form. So whenever it is growing, so you can see this is graph, right? And you can see this is different, this is different. So two different graphs are, but they are growing in a disconnected form. But in a Prim's, they are growing in a connected form, right? Next, Prim's algorithm grow a solution from a random vertex by adding the next cheapest vertex to the existing tree. So in the Prim's, the first edges you have to be selected as a random, any edges you can select it, okay? And the next is the cheapest. This is the way. And what are the cheapest? Which is that particular. Suppose you are selecting here randomly this vertex, okay? So the next vertex you have to be selected from these options, right? Suppose there are three options which is connected to, because the tree is growing in a connected form. So obviously you have to be select any edge which is connected to that particular graph, right? So there are three options. Suppose there are three options. So you have to be select the minimum weighted edges from between of them, right? But in a Kruskal algorithm, grow a solution from the cheapest edge by adding the next cheapest edge to the existing tree. It is not basically having a condition that you have to select a next edge which is connected to the particular node. If suppose there are edge, this one is having a minimum weight, so you can choose another weight which is having a least weighted edges, right? And it is not necessary to connect these two edges or these two graphs to each other, right? So simply you can choose a Prim's when you want to create a tree in a connected way, or either you can choose a Kruskal if you want to create a tree in a disconnected way, okay? And the last major point, Prim's algorithm is a faster for dense graph. Suppose there is a dense graph, is a very density graph. So it is, you can use a Prim's algorithm, and Kruskal algorithm is faster for a sparser graph. So this is basically the main difference between of them. So you can apply either Prim's or either Kruskal, but if you want to do some faster work, so if you are having a sparser graph, you can apply a Kruskal algorithm, and if you are having a dense graph, you can apply a Prim's algorithm. Prim's algorithm is better with a dense graph, right? So suppose you are having a dense graph, it doesn't mean that if you are having a dense graph, you cannot apply a Kruskal algorithm. You can apply it, but the processing is slow as compared to the Prim's. Got my point? And if you are having a sparser graph, so similarly you can apply a Prim's algorithm also, but if you need a run faster that algorithm, so you can apply a Kruskal algorithm for that particular sparse graph, okay? So these are the two topics which is from the greedy algorithm, that is Prim's and Kruskal, which is used to create the minimum spanning tree, okay? So thank you so much. In the next class we will discuss about the next topic. Thank you.